Hi, I'm Vanessa Speight from the University of Sheffield, and I'm here today representing the Environmental and Water Resources Institute of ASCE and the WDSA History Project. The purpose of this project is to document the history of water distribution system analysis. An important part of this is interviews with people who've been involved with this kind of work and have made significant contributions to the field. Today I'm going to be interviewing Mirjam Blokker from KWR. She's been at the forefront of water distribution system analysis since the early 2000s and continues to make contributions to the field. Her work with research in the Dutch water systems has really contributed to our knowledge of water quality and distribution systems. This interview is being conducted on the 4th of September in Leicester, United Kingdom, during the Computing and Control for the Water Industry Conference. So Mirjam, you've been working now for 15 plus years in the water distribution field. Can you tell us how you first got involved?
I first got involved in 2003. I worked in telecommunications before, and well, there was the burst of the internet bubble and everything, so most people lost their jobs then. And I thought I really wanted to work in something relevant and in research, but applied research, so not at a university. And I applied for a job with KWR, which is the Research Institute of the Dutch drinking water industry. And I started working basically on demand modeling. So it was an interesting way of getting involved in the drinking water industry, actually.
So how do you think your background, because you're not a traditional water engineer by training in your bachelor's, how do you think that influenced how you did the work and then subsequently that you went on to study water engineering?
When I first started with KWR, they said, well, nobody is trained really as a distribution engineer, so that's fine. But they were a little bit reluctant with somebody who came from such a, well, commercial background. But by training, I'm a physical or applied physics engineer. So I know how to model things, and I do know a little bit about the physics of water flowing through pipes and interaction with walls and things like that. So I never really thought it was a big problem, and actually I think I'm better equipped for modeling than your standard civil engineer who's more into the bulky things and yeah.
So then you decided to go do a PhD later on in your career. What motivated that decision?
I started working more after I did my master's. I never really thought I would do a PhD at all, really. I never wanted to stay at a university, especially at that time in Delft in applied physics. There were a lot of grey old men that wasn't really very attractive for a young person to stay and do their research. And also I thought it was a little, I guess specifically for physics, it's very much on the detail and fundamental research, which did not really appeal to me. But then I started working with KWR, and there's lots of things you can do, and there's lots of research directions you can focus on, maybe a little bit too many. So actually trying to think of finding a way to go more into depth for a particular subject was the motivation for actually doing a PhD. So I could really focus on that and tell everybody that this is my topic now, and I cannot do all that administrative coordinative work for a while. I'll first focus on the in-depth knowledge. And I think it was a really good decision. And when I started to do my PhD, I already had developed the model, the basic model for the demand. But it gave me the opportunity to really write papers and prove the applicability and things of that. So I like that.
Great. Well, you've collaborated with a lot of interesting people, so can you talk a little bit about some of those people and how you work together with them?
With many of them. I've worked with Steve Buckberger, as he's probably the father of demand modeling in our field. So the first time I ever went to a conference, WDSA conference, the first person I met was actually Steve Buckberger, so that was a good introduction. He really welcomed me into the field, and he was the moderator of that session that I first presented my model in. We've been discussing how to model things, and he's been willing to share his data on the Milford demands and see how we could apply both models to the same data set. And he didn't really mind that part of my model was better in some ways and his was in others, so I think it was a good collaboration there. And of course he was also on my PhD committee, so that helped. I mean, he really had a good understanding of what I did, so that was really nice. And then there's been collaboration with several of the UK universities, so we have a lot of access to the Dutch water industry and data sets and real life data, so that's always very interesting. And then anybody who would do modeling and just not stay totally focused on theory, but actually want to share, to test it on a real system, we're happy to share data with them. So there's been some students in Exeter and in Sheffield that would do some work, and we could provide some data. And lately we're more collaborating now with University of Sheffield and really coming together more on discoloration, not just this is the way the Dutch look at it and this is how University of Sheffield looks at it, but it is coming together more and more, and we both see how microbiology influences the discoloration, and trying to understand more and model that and do measurements and compare Dutch and UK systems, and it will be interesting.
So do you think that having SimDM as sort of package model has opened up doors to work with people more than just having an idea, or having a sort of software tool? Has that been useful in your collaborations? It is a model that is more or less easy to apply. You do need a lot of data for SimDM to really run for your specific area, but you can use or reuse many of the data that we found. I was expecting actually that more people would use our basic data set than our model, but that has not really happened. So we have a lot of information on how often people would take a shower or for how long, and the variation in that, and people have not really been using that data, but they have been using the modeling approach. And I do think that it helps a lot that we can show the variation of all hydraulics in distribution networks with a stochastic model, and that would really help in trying to explain why certain phenomena happen related to hydraulics, and not just your standard model that would only give you more or less a minimum or median flow, but we can really look at all the changes. And I think that helps in trying to understand hydraulic influences on discoloration, or on transients, or on flow reversals, or stagnant zones, or whatever. I think there's a lot of potential there, even that hasn't been explored all. So have you worked with some young engineers and mentored them and welcomed them into water distribution also?
I have. I try to. I think it's very important, and I always encourage our new colleagues to come to these sort of conferences and meet all the people and hear what's going on. I have been co-authoring quite a number of papers in this session that people asked, "Oh, you're not presenting that?" No, my new and young colleagues are, and doing very well. I think it's very important to encourage them and try to explain a little bit, or make them benefit from all the information and knowledge that I've gained over the years. They can contribute new things, and I can have the broad picture and just talk to everyone and share ideas, and hopefully they'll do something with it, but it's actually a nice way of doing it.
So do you feel you have a good balance of research and practical, or do you wish that it would go one direction or another a little more?
Well, compared to many of the others in this area, we have quite a good practical application, especially testing our research ideas, hypothesis in practice, I think is where we have a good balance. But the practical implication or implementation of things could be improved. And this is sort of a conservative industry, so it takes time to really implement things and convince people that this is the way to go forth. And many of the water companies don't really have a good view of what the cost and benefit of their current approach is, let alone what the improvements would bring them. So this is a challenge, and something that I guess many of the universities should learn too, that theory is not everything. There's many practical issues why your theory would never be applied, and you don't have to be right the third digit. So that, well, I think is also a challenge to bring practice and research more together.
So you mentioned it's a conservative industry, and there are not very many women who are in this field. So what's been your observations of being female in this quite male-dominated area?
Interesting question. I think in the research field I don't see a lot of difference or how you're perceived. But in the industry itself, there are not a lot of women, and the women that now are sort of entering the system or the industry are usually not the really technical people, or they might be technical by training, but within a year they are the managers or team leaders, and they're very good at that. But they don't really have the technical influence there. I think I'm not really sure what that means, but it's an observation.
But did you feel yourself that you were drawn or pushed towards administrative roles versus technical roles, or did you feel you got to choose your own direction? Well, within KWR there is always a need for people who do project management, who are team leaders as well. And they have been pushing me, but it's just not for me. And I think the position of senior scientific principal scientist, whatever we'll call it, is much better, where you can coach people, but in the technical aspects and not do all the administrative things. And I think they tend to ask women more often for those things. So where do you see the future of water distribution system analysis going? What's the direction we're heading? The most important thing, I think, well, at least for the research of KWR in the Netherlands, is more and more onto asset management, rehabilitation planning, but with all the uncertainties
modeled into that. So bringing information together from failure registration, pipe material degradation, and all that sort of thing, but with a feel of you should replace within or between 12 and 15 years, or I don't know if we can really narrow it down to that, but not just saying this is the absolute best solution according to our Pareto front, but really help the practitioners understand that they have some sort of leeway in choosing what they actually want to do, and then still be very close to that optimum solution, but in a more practical way. So I think that's one of the main things that we should be focusing on next.
That's great. Do you have any final comments to add?
I don't.
Okay, thank you.